back for quiz 5. Let's start with problem 1a. It says if loop integral C f dr is greater than 0, then f and c are flowing in the same direction. There's not really much to say about that by definition about how loop integrals work. If the integral is greater than 0, then they are flowing in the same direction, and if it's not, then they're flowing opposite directions. Question B states that for every continuous vector field big F, there's a function little f, such as the gradient of little f is the vector field big F. This isn't true because if that is true, then the vector field is definitely continuous, but it doesn't have to be the other way around. For example, if this vector field has more than one variable, such as x, y, and z, if all three partial derivatives are not continuous, then this is not going to be true. Also, the question specifically states that there will be a scalar function. However, if this vector field has more than one variable going on, the gradient is never going to be a scalar function. So that's another thing making that question false. C says the vector field f x y equals 2y squared negative 2x. This vector field is rotational, so let's just map it out and see if it is. So after graphing this vector field, it appears to be moving like this, making it rotational. D says that for all curves C with a parametration R of t and continuous vector fields f, we can always write that the loop integral of f dr is going to be the double integral of q of z minus p of y dA. Firstly, this is wrong because the bounds are kind of weird. It should be q of x minus p of y, not q of z minus p of y. And secondly, this only works if all the partial derivatives involved are continuous, which the question doesn't specifically specify. Question E says that if f is a continuous vector field independent of the path in domain D and f is open and connected, then f is conservative. Again, this is true. This is just the definition of what being conservative means for a vector field. So F, none of above is wrong.